In this video, we're going to show you how to set up absolute value inequalities, but focus on the why you set them up the way that we teach you. Let's look at two samples. The absolute value of x plus 4 is less than or equal to 3, and the absolute value of x plus 4 is greater than or equal to 3. The first one, because it's a less than symbol, you set it up as a continuous compound inequality, where you set x plus 4 in the middle so that it's greater than negative 3 but less than 3. Now let's look at the bottom one, where x plus 4 is greater than 3. We set it up as two separate inequalities. X plus 4 is less than or equal to negative 3, or x plus 4 is greater than or equal to positive 3. But why do we set them up this way? Why do our symbols face the way they do? Let's go ahead and solve these first, just to demonstrate the solving of inequalities. So here I have my x plus 4 in the middle. So again, it's a compound inequality. So I can simply do subtract 4 to get that away from x, but I need to do it on both ends because they represent two separate inequalities. This end, I end up with negative 1 is less than or equal to x, and x is now greater than or equal to negative 7. So you can see that our interval would be all x values in between negative 7 and negative 1. And I use the square brackets because my original symbols had an equal sign to it. Now let's take a look at the second one. Let's go ahead and solve this one. It was two separate inequalities, so it was set up here as x plus 4 is less than or equal to negative 3, or x plus 4 is greater than or equal to 3. So I'm going to start with the left side. Let's go ahead and again, we're going to subtract 4 to isolate x, subtract 4 from the other side. This is now negative 7, bring down my symbol, and this is now x. X is now less than or equal to negative 7. Let's do the one on the right. Again, subtract 4, and I now have x is greater than or equal to negative 1. Seems very similar to the one previously, but there is a major difference. We have two separate intervals now. The x less than or equal to negative 7 means it comes from infinity on the negative end, which is always on the left, up to, but it does include negative 7, so square bracket on the right. Remember, infinity always gets a curved parenthesis. This is or, and the math symbol for or is the union symbol. And my next interval starts at negative 1, and it's greater than negative 1, so it goes to positive infinity. But now I want to focus on the why. Why are we setting them up this way? Why do they come out this way? Let's look at the why for the first one. X plus 4 is less than or equal to 3. To help you understand, let's look at the graph of a general absolute value function. Let's take y is equal to x plus 4. If you are not familiar with the absolute value function's equation, it makes a v, and I'll do a demonstration by doing a table of points. So I went over here and made a table, and I started with what would make the absolute value in the middle become 0, because then that would give me y is equal to 0. Well, I happen to know that negative 4 plus 4 is 0, so if my x was negative 4, my y would be 0. At this point, I pick numbers to the left and the right on the number line of my negative 4 to see how far up or how angled is my graph. So as you can see, I went to negative 5, and if you had plugged in negative 5 for x, you would end up with the absolute value of negative 1. But of course, the absolute value of that is 1. So when x was negative 5, y was positive 1. So I went to the other side and took negative 3, and the same thing would happen. Negative 3 plus 4, that would give me the absolute value of 1, which is still positive 1. So at negative 3, I went to positive 1. And these are straight lines from that point. Let's look at this graph closer up. What values of x will give me numbers less than 3? So if I take a look at the actual graph and think about this, I'm going to go down here. And so right now we know that if we put in -4, that becomes 0, and 0 is less than 3. Now, according to our solving, it said that it was all numbers from -7 to -1. Well, let's take a look. So if we look at -6, for example, you're thinking, well, -6 is not less than 3. But you have to remember, this is the x value that goes into the function. So if we take our x plus 4 and we put x as -6, we have -6 plus 4. We're going to take the absolute value then of -2, which would be 2, and 2 is definitely less than or equal to 3. Now, if I could extend my graph here and go out to, say, -8, well, -8, I'm going to plug that one in. So -8, plus 4. Well, that's the absolute value of -4. And the absolute value of -4, of course, is 4. And 4 is definitely not less than or equal to 3. So clearly, I can only go as far as -7 this way before my x's. Once x is substituted in, it gives me a false statement. Now let's take a look, going the other way from 4. So we'll take, say, -3. So we take the absolute value of -3 plus 4, because again, these are our x values. So -3 plus 4, that's going to give me 1. And the absolute value of 1, of course, is 1. And 1 is less than or equal to 3. And then if we go above -1, because our interval was supposed to be -7 to -1, if I go above that and pick, say, x as 1 and plug that in, the absolute value of 1 plus 4 is equal to 5. So the absolute value of 5 is 5, and 5 is definitely not less than or equal to 3. So therefore, when we're talking about an absolute value being less than a number, it's going to be a continuous equality. It's going to be the numbers in between 3 and -3 if x is these numbers. Now let's look close up to x plus 4 is greater than 3. So when we set that up and we solved, we set it up with two separate inequalities. Because remember, our interval for that one, we had the same numbers, but our interval was two separate intervals. So let me just do a quick here. So we had -7. And when you're reading this, you're saying, okay, numbers greater than, or it should be, after -7 to a negative infinity, we're talking about numbers out here. And -1, to infinity, we're talking about numbers out here. Okay. Does that match with our graph? Well, let's think about it. Let's go ahead, and it is kind of weird. The right side seems normal. Yeah, that makes total sense. For some reason, that's easy for people to understand. But we'll start with the left side, the more difficult side. You take a look at your number -7, and you're thinking greater than, so you're thinking to the right, except in value, if I want to go below -7, those are less than -7. So in our case, although it's greater than 3, the numbers to the right here wouldn't work. So let's pick a couple. Let's take, say, our graph went out here. Let's take -8. So let's plug it in. -8 plus 4, the absolute value of that. So the absolute value of -4, which the absolute value of that is 4. And in this case, we were saying what numbers are greater than or equal to 3. So this is true. So -8 works. So everything on my graph going this way is going to work. I could take -9, for example, plug that in. Let's go back to the right side, -1. Well, if it's supposed to be -1 to infinity, any number above -1 should work. So let's take the 2, for example. Let's plug 2 in on the right. +2 plus 4. take the absolute value of that. It's the absolute value of 6, which is 6, and 6 is definitely greater than or equal to 3. So you can see that the outside of those two numbers, that is my interval. So it's basically this part of the graph and that part of the graph. So again, I have two separate inequalities. It could be anything over to the left of -7 or to the right of -1. And again, I'll double check the middle doesn't work by taking -3. So if I take -3 for x and plug it in, again, the absolute value of -3 plus 4, which is equal to the absolute value of 1, which is 1, and 1 is not greater than or equal to 3, which is our original statement up here at the top. So it's clear that it has to be two intervals below -7 and above -1. So that is why we set them up the way we do, depending on their original inequality symbol. Hopefully this video will have clarified the information a little bit more to help you remember which setup you're to use for which inequality when you're doing absolute value inequalities.